Okay, so here's a walkthrough on adding and subtracting radicals. The answer to question number 1 on our handout today was, how do you add or subtract radicals? Our answer was, to add or subtract radicals, simplify all radicals that can be simplified, then combine like terms. Now, the thing you need to take into account when you do these questions, we're going to start with number 5, is that there are two different types of roots. There are square roots and there are cube roots. These are square roots. Square roots look like this. A cube root would look like this, but with a little 3 there. We don't have a little 3 there, so we're talking about squares. When we're talking about square roots, that means that we're looking to find squares underneath. So the perfect squares are the factors that we want to use. If you don't remember what the perfect squares are, a couple of them are like this. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And the numbers go on from there. 7 times 7 is 49. Then we get 64, 81, and 100. We probably don't need to go any further than that. But so these are the perfect squares. I'm looking for these factors. I'm basically asking myself, like, which one of these guys will divide into these numbers here? Which one of them will divide in? So I'm looking at this list. I see 4 divides into 24. I don't know how I'm figuring that out. We've done this for 2 lessons, but hey, sometimes we get rusty. I'm going to take my calculator. Your graphing calculator or otherwise, and check this number. I'm going to say 24. What is that divisible by? 24 is divisible by 4? Yes, it is. It's divisible by 4, and the leftover is 6. The quotient is 6. So that means that 4 times 6 is equal to 24. So I'm going to split this into 4 times 6. I picked 4, not just because it was a number, not just because it was a factor, but because it's one of these factors. Okay, 4 times 6. Now I need to check 96. I said, okay, is 96 divisible by 4? Yes, it is. But that's a big leftover. Let me see if I can get a bigger factor to go into it. 96 divided by 9? Nope. 96 divided by 16? That's the number we're going to use. 16 times 6. So we break this up into 16 times 6, put the square root back over it, the minus 2 still hangs out front, the square root over these guys, and the 5 goes back in front. Now, an easy way to simplify these is to say, what is 4 equal to? I want a square, so the square root will let him through. Right? He's the bouncer, he's only going to accept you if you have a 2. That's your invitation. So this 4 is equal to 2 squared. This 16 is equal to 4 squared. Now I ask myself, who has an invitation? The bouncer is going to check everybody in line, see who has an invitation. This guy does. He hands over his invitation, and he can step on through. Same over here, hands over the invite, go right on through. So on the outside on the left, I have a 5 times 2. The 6 is still stuck underneath, minus 2, then I have times the 4 that came out, and I have a radical 6 still stuck underneath over here. I can simplify these, 5 times 2 and 2 times 4. 5 times 2 is 10, so I've got 10 radical 6, minus 8 radical 6. And you can think of these like objects, right? If I have 10 radical 6's, and you subtract 8 of them, I'm going to get 10 minus 8 is 2 radical 6's. So that's an easy one. Let's take a look at a cube next. If you're in class and you think you understand this already, now would be a good time to pause, see if you can do this question yourself before you move on. Okay, so now I'm going to do it, which for you should be a check. You have already done this. what we're looking for now is we have a different bouncer at this club, different bouncer. He doesn't want 2s in order to let you through. He wants 3s. So, what are the 3s? What are the cubes? Well, 2 cubed is 8. It's 2 times 2 times 2. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. And 7 is 343. So these are the cubes. Now, which one of these goes into negative 40? 8 does. So I'm going to break this guy down into 8 times negative 5. Put the cube root back over him, put that big negative 3 right out front again. On the right side, what can I turn 320 into? Well, if you check your calculator, 320 divided by 8 doesn't work. Or it does, but it leaves you a big number left over. 320 divided by 27 doesn't work. 320 divided by 64, that works. 320 is equal to 64 times 5. Put the cube root back over him. Put the plus 3 in front. Now I'm going to simplify my cubes. I need cubes, or 3 exponents, the exponent 3, in order to make it through. The bouncer's not going to take any other kind of invitation. So this 8, just in red, this 8 is going to be rewritten as 2 cubed. The 64 is going to be rewritten as 4 cubed. When the bouncer asks who is an invitation, the 2 to the 3rd is going to hand over his, and he gets to go right on through. The 4 to the 3rd is going to hand his, and step right on through as well. So when I rewrite, I've got negative 3 times 2, cube root, with a negative 5 still stuck underneath, plus 3 times 4, cube root of 5. I'm going to multiply the coefficients in the front, but I've almost forgotten a step. Not really. I knew it was coming. This negative here gets to come out, because we had a rule the other day that says negatives can come out of cube roots. You have it written in your notes. Negatives can come out of cube roots. Not square roots, only cubes. So that negative can come out, and he's going to make this negative sign out here into a positive. If you're not sure why, 2 negatives, oh, negative and negative, that becomes positive. Okay? So this negative underneath here is no more. We didn't want them under there anyway, because look, now these guys are actually equal, they're like terms. So let's simplify this a little bit. Positive 3 times 2, it's going to be 6, cube root of 5, plus 12, cube root of 5. And if I've got 6 cube root of 5s, and you've got 12 cube root of 5s, and we add them together, we collectively have 18 cube root of 5s. You know, because 6 plus 12 is 18. Okay. And let's do one 3 term with a square root. If you get a 3 term with a cube root, it's the same deal. We're just going to do number 15. One thing you should notice, just right off the bat, math is about patterns, intuition, habit. So this guy right here, does it look like I can simplify him? I don't think so. 3 is not going to get any smaller than 3. So I don't think I have to worry about him. Now ask yourself, are these square roots or cube roots? So am I going to be looking for square numbers or cube numbers? I'm looking for square numbers because these are square roots. So I'm going to look at the squares. The squares were 4, 9, 16, 25, 36, 49 and 64. I didn't even need to go that far. But I want to find square roots that divide into these. Now, do any of these divide into 3? No, I didn't think so. Do any of these numbers over here, do they divide into 27? Yep, 9 does. So I'm going to break 27 up into 9 times 3. Put the square root back over him, drop that 3 back in front. Can anything go into that radical 12, any of these guys? Yeah, 4 divides into 12. 12 can become 4 times 3. Square root. Bring down that negative sign. Bring down the other terms at the beginning. Negative 2 radical 3. Now I get a couple terms that want to come out. So when I look at this, I'm going to say, alright, well 9 is actually just 3 squared. 4 is equal to 2 squared. And now that I have some squares, the bouncer is checking for invitations. He says, hey, does anybody have a 2? This 3 over here, he says, yeah, I do. So the bouncer says, give over your invitation, step on in. Over here, this 2 hands over his invitation, and he can go right on through the square root as well. So let me rewrite this, just keep everything neat. Negative 2, cube root of 3, plus 3 times 3. Right, so the 3 times 3. Who's stuck underneath? That guy. So I've got 3 times 3, square root of 3, minus 2, square root of 3. Take a second to figure out where those numbers came from. Back up if you need to. I can simplify just one thing. 3 times 3 is actually 9, right? So really what I'm asking myself is, what is negative 2 radical 3 plus 9 radical 3 minus 2 radical 3? Really, I'm just adding up the coefficients. Well, if you've got negative 2 rad 3's and I add 9, so negative 2 plus 9 is 7. So this right here is 7 rad 3 minus 2 rad 3 brought down. 7 minus 2 is 5 radical 3. Okay, so it's really just about what we said in the beginning. Simplify all the terms themselves, and then you should find like terms and you can combine them. If you have any more questions, please feel free to contact me and ask me tomorrow in class.